Hello everyone, today we're going to talk about atoms and their different parts, and we're going to get into the basics of electrons with that. Okay, so what do we know so far about atoms? We know that protons and neutrons are both found in the nucleus. We know that protons have a positive charge and that the number of protons identifies an atom. So if we know that we have 3 protons in an atom, that is specifically always going to be lithium, or if we have 1, that will always be hydrogen. Neutrons are also found in the nucleus. They have no charge, but they do have mass, so they make the element heavier because they're contributing to the mass of the element. Then we have the electrons, which surround the nucleus in a cloud-like area. They have a tiny mass. They are a tiny, tiny, tiny portion. They have so little mass that when we look at the mass of an atom, we just kind of ignore what mass they bring. And we know that they have a negative charge, and this negative charge is very, very important for bonding. So keep that in the back of your mind of how important electrons are going to be when we talk about bonding. Typically, this is how we see the model of the atom. And when we look at the electrons are the parts that are surrounding these nuclei over here. Now, if you take a look at these are representing all different atoms. And you notice that there's some differences when you look at the electrons. For example, up here, we only have 1 electron that's going around. In this one, we have a bunch. In this one, we've got 3, and we've got a bunch more. And if you also look, you see that it looks like they have different orbits going around the nuclei. For example, hydrogen, which is up here, only has 1 little orbit. Carbon has 2 orbits. Lithium has 2 orbits. And sodium has 3 orbits. The orbits that are here are known as energy levels. So the closer you are to the nucleus, the electron is to the nucleus, the lower the energy level. And as electrons get farther and farther away, for example, if we look here, we see that this electron over here is the farther from the nucleus, right? The distance. Okay, that means that it has a higher energy level. So any electrons that are close to the nucleus are going to have low energy levels. Any electrons that are far are going to have high energy levels. All electrons have a lot of energy. They are the hyperactive particle within an atom. And some electrons have more energy than others. So again, to remember, the electrons closer to the nucleus have lower energy levels, and the ones that are farther from the nucleus have higher energy levels. Those highest energy electrons are called valence electrons, and that's what you learned a little bit about yesterday when you were doing the gizmo. What's so special about the valence electrons? The thing that is most important with the valence electrons is bonding. And we're going to talk about that more later. Bonding is when you have different atoms that are chemically joined together. Chemical bonding is important because that's when we take different atoms and put them together and we end up with a chemical change. For example, we could have 2 hydrogen atoms and 1 oxygen atom, and they bond together due to their valence electrons, and they create water, which is something very important to us. how do we know how many valence electrons an atom has? So there's a couple of different ways we can do this. Yesterday, you guys worked with the gizmo that looked kind of a little bit like this. So if you have a diagram that's like this, it's pretty easy, right? You've got the electrons that are closest to the nucleus, which are those right there. You also see they're moving kind of slowly. That's because they don't have a lot of energy, because they're closest to the nucleus. Remember, close means low energy. And then you can see this kind of purple line or area, okay, is where there are some more electrons that are out there. Those are the farthest from the nucleus in this atom. So if we were going to look at this atom and figure out how many valence electrons are the electrons that are farthest from the nucleus in the highest energy level. So if we were going to count them, we would say, okay, I have 1, 2, 3 valence electrons. So this would end up being 3 valence electrons. And when we write the abbreviation for electrons, we write E with a negative sign. Now you take a look. So if you look at this diagram of an atom and you were asked how many valence electrons does it have, how many would you say? If you said 1 valence electron, you would be correct. That 1 valence electron that is floating around out here is the farthest from the nucleus. You can see it going around. Okay, so I'm aware that you will not always have your element builder gizmo available. So the other way that you can find out how many valence electrons an atom has, ta-da, the periodic table. You should have seen in your element builder yesterday that the periodic table has all of the elements on it, and it's organized by patterns, and one of those patterns is the number of valence electrons. Let me show you what I mean about the patterns. Here I have 2 different elements that I've created. So we're going to look at this one first, which is lithium. And if you look at lithium, you will see that it has 1 valence electron that's found out here. It's the farthest from the atom's nucleus. Now let's take a look at the second atom that I have here that I created, which is sodium. And when I start this one, there's the electrons moving around. When you look at this one, what do you notice about the valence electrons? Well, if we look at the electron that is out here, that is the farthest from the nucleus of the atom. There is only 1. So we have these 2 elements, sodium and lithium, that both have 1 valence electron. Now, if we take a look here on the periodic table, you'll be able to see that lithium and sodium are found over here. And they are in the same column. So if we looked at that, we can draw the conclusion that all the elements in this same column, which columns are called groups, are all going to have 1 valence electron. What gets even easier is as you move from left to right, the columns all have the same amount of valence electrons. So this column right here, which is the orange, is going to have 2 valence electrons. Now we're going to skip over the middle for right now because those are special. But if we go over here and start at this column, which is column 13, this whole column will have 3 valence electrons. And if we keep moving, maybe you can figure it out now and figure the pattern. The carbon family has 4 valence electrons. Over here, this column, the nitrogen family is what it's called. This has 5 valence electrons. Group 16, the oxygen family, has 6 valence electrons. The fluorine family here, which is also called the halogens, and we'll go into that later, has 7 valence electrons. And then this last column here has 8 valence electrons. What you'll notice is when you're looking at the periodic table, the first 2 columns that are up here, the number on the top matches the number of valence electrons. Now again, we're skipping this part right now of the periodic table because we'll talk about that later. But over here, in these other columns, you'll see that they all have, oops, sorry, I did a bad job of circling that. They all have the second number of the title. I'm really bad at this. I apologize. I should be circling the 4. Maybe I'll try the highlighter. So 5, 6, 7, and 8. So this is telling us, I'll go back and do the 4 and the 3 for you. This is telling us that this group has 3 valence electrons, so it's the second digit, 4 valence electrons. So the way we would write this, if I were writing this, I would say this has 2 valence electrons. This group would have 3, 4, 5, 6, 7, 8. The periodic table is really, really easy to read, and you're going to learn this more. It's full of patterns. Now that you know how to find the valence electrons, you can draw the Lewis dot structures or dot diagrams. A Lewis dot structure diagram is a picture view of an element showing how many valence electrons it has. So there are 2 steps to this. The first step is you always write the symbol of the element. And then you draw dots for how many valence electrons that element has. So let's take a look and let's do magnesium. Okay, so if I take a look at my periodic table, I see that magnesium is located right here. And that is in the second column, so it has 2 valence electrons. So what I would do is I would write the abbreviation for magnesium, which is Mg. Whenever we do abbreviations, we always do a capital letter followed by a lowercase letter. Now, because it has 2 valence electrons, I would draw 2 dots. So we never fill in 2 dots on one side of the symbol until they're all filled in. So I would put 1 here and then 1 here. And that would be my dot diagram. Let's try one more. This is a very simple concept, so hopefully you'll get it. Let's try fluorine. Fluorine, if you take a look, is right over here. It's in column 17. Now remember I explained that the second digit is how many valence electrons it has. The max number of valence electrons is 8. So 17, in column 17, fluorine is going to have 7. So what I do, let me put my periodic table away, is I will write the symbol for fluorine, which is F. So that's pretty easy. And I have 7 valence electrons. So this is what I meant before we fill in all the sides before we double up. So I'm going to put 1, 2, 3, 4. Now each side has 1, so now I have to start doubling up. 5, 6, 7. So that's what my Lewis dot structure would look like for fluorine. I hope that helped with everything. Your assignment is on Google Classroom. Let me know if you have questions.